Earth feels like the perfect home for life. Liquid water, a stable star, a thin, protective atmosphere. For a long time, we believed this balance was rare, maybe even unique. But the universe is vast, and Earth may not be its best attempt. Out there are worlds slightly larger, slightly calmer, and possibly far more forgiving than our own. Planets where seasons may be gentler, climates more stable, and time itself works in favor of life rather than against it. These are not science fiction worlds. They are real planets, orbiting real stars, discovered by careful observation and quiet data, places where life might have an easier path, not just to survive, but to endure. If life is shaped by its environment, then some environments may be better than Earth ever was. This raises an uncomfortable question. What if Earth is not the ideal world for life, just the one we happen to be born on? The first planet competitive to Earth is Kepler, 442b. This distant world orbits a calm orange dwarf star roughly 1,200 light-years away in the constellation Lyra. That distance alone places it far beyond any realistic human journey. Even with our fastest technology, reaching Kepler 442b would take millions of years. What makes it remarkable is not how far away it is, but how stable it appears to be. Kepler 442b is slightly larger than Earth, with stronger gravity that could help it retain a thick atmosphere for extremely long periods of time. Its parent star is smaller and cooler than our Sun, but far more stable. These stars burn slowly and evenly, providing a steady energy output for tens of billions of years, far longer than Earth's remaining window. The stability matters. Life benefits from consistency. Fewer stellar outbursts, fewer catastrophic climate shifts, and long stretches of calm conditions create an environment where life has time to adapt, diversify, and endure. Kepler 442b receives just enough energy to allow liquid water to exist on its surface without the intense radiation that threatens many other exoplanets. Its longer orbital periods suggest slower seasonal changes, reducing environmental stress over time. But there are uncertainties. We do not yet know whether Kepler 442b has oceans, continents, or an atmosphere at all. Its higher gravity could limit how large complex organisms become. And its redder starlight would shape life in unfamiliar ways. Still, Kepler 442b represents one of the clearest examples that Earth may not be the most forgiving place life could exist. In some corners of the universe, conditions may be even kinder. The second planet competitive to Earth is Kepler 452b, often described as Earth's older cousin. Kepler 452b orbits a star very similar to our Sun, about 1,400 light-years away in the constellation Cygnus. Its distance makes it unreachable. With current technology, a journey would take millions of years, even at extraordinary speeds. What makes Kepler 452b stand out is its age and scale. The planet is larger and more massive than Earth, which may allow it to hold a dense atmosphere and maintain surface water for longer periods of time. Its star is older than our Sun, meaning Kepler 452b may have enjoyed billions of additional years of stable conditions, time that life could use to grow more complex and resilient. Kepler 452b sits within its star's habitable zone, receiving energy levels comparable to Earth's. But unlike Earth, which still experiences dramatic climate shifts, Kepler 452b may have benefited from a longer, calmer environmental history before its star began to brighten with age. That extended stability could give life a major advantage. However, there are limits. As the star continues to age, Kepler 452b may already be approaching a warmer phase. Its larger size could also mean stronger gravity and a thicker atmosphere, possibly leading to higher surface pressure. We do not yet know if oceans exist there, or if its atmosphere supports complex chemistry. Still, Kepler 452b shows us something important. Earth is not the only world that could enjoy long, stable conditions. Some planets may simply have had more time to get life right. The third planet competitive to Earth is Kepler 62f. This world orbits a smaller, cooler star, about 1,200 light-years away, in the constellation Lyra. Its parent star is far dimmer than the Sun, but also far longer lived, offering a stable source of energy over tens of billions of years. Kepler 62f is slightly larger than Earth and sits near the outer edge of its star's habitable zone. That position may seem risky, but it could actually be an advantage. A thicker atmosphere or strong greenhouse effect could keep the planet warm while protecting it from radiation and extreme temperature swings. Unlike planets around highly active red dwarfs, Kepler 6 2f star appears relatively quiet. This reduces the likelihood of frequent stellar flares, stripping away atmospheres or disrupting surface conditions. Kepler 6 2f likely experiences longer years and slower seasonal cycles. Change happens gradually. Climate extremes are softened by time, giving life more opportunity to adapt instead of constantly struggling to survive. There are still unknowns. The planet may be covered by deep oceans or ice. Its distance means we cannot yet observe its atmosphere directly. And its low energy input may require stronger internal or atmospheric heating to sustain surface water. Even so, Kepler 6 2f represents a different kind of advantage. Not a dramatic world, but a patient one. A planet where life may have had the luxury of time, consistency, and calm. And in the universe, those qualities can matter more than perfection. The fourth planet competitive to Earth is TOI 700d. Unlike the others, this world is relatively close, about 100 light years away in the Dorado constellation. Even at that distance, reaching TOI 700d with current technology would still take millions of years, placing it far beyond any practical journey. TOI 700d orbits a small red dwarf star that is unusually quiet and stable compared to most stars of its kind. That matters. Many red dwarfs bombard their planets with intense flares, stripping atmospheres away. TOI 700's calm behavior increases the chances that this planet has retained its air and surface conditions. The planet is roughly Earth-sized and sits comfortably within its star's habitable zone, receiving just enough energy to allow liquid water to exist. Because red dwarf stars burn slowly, TOI 700d could remain stable for tens of billions of years, far longer than Earth's remaining lifespan. But there are challenges. TOI 700d may be tidally locked, with one side always facing its star and the other locked in darkness. This could create extreme temperature differences unless a thick atmosphere redistributes heat. Its star's red light would also change how energy is absorbed and how any potential ecosystems function. We still don't know whether TOI 700d has oceans, continents, or a protective magnetic field. Yet its proximity, stability, and long lifespan make it one of the most promising places where life could quietly persist, possibly under conditions even more enduring than those on Earth. In a vast universe, sometimes closeness matters as much as perfection.